I'm going to explain how to use an interactive simulation that models a Pitot tube. And essentially what this is a way to measure a velocity of a fluid stream by measuring a pressure difference. So the pressure difference here is due to a fluid and manometer. The simulation allows you to change the density of that fluid, and that will, of course, change the height. It doesn't, of course, change the pressure difference. The simulation also allows you to change the velocity of the fluid. And essentially what a Pitot tube is doing is measuring a difference in pressure and then calculating the velocity from that. So one pressure, let's call this 0.1. That's the stagnation pressure. And let's call this 0.2. So if you can follow this, the outside of that tube is the other side, the lower pressure, the opening, so it's exposed to the velocity. So the velocity at 0.2 is the velocity of fluid. The velocity at 0.1 is 0. It's the stagnation point where this fluid here is not flowing. And what the Pitot tube is doing is taking advantage of the Bernoulli equation, which in this case is the pressure at 0.1 plus 1/2 the density of the fluid. That's not the density of the manometer green fluid, it's the density of the flowing fluid, and the velocity of the fluid at 0.1 squared, and that's equal to pressure at 0.2, and again 1/2 velocity squared. This is 0. The fluid is not flowing at 0.1. What the Pitot tube does is measure this pressure difference and then calculates the velocity. So let's look at that interactive simulation. So here's the interactive simulation. You see at low velocity, not much of a pressure difference, and so as I increase the velocity, the height of manometer increases. If I increase the density of fluid, then of course that height decreases. I can instead change the height, and of course the velocity increases. So if you like, this corresponds to, we would measure the height in the system and then back calculate the velocity. So the idea here is we're taking advantage of Bernoulli equation to measure velocity and therefore flow rate with a very simple measurement.